Welcome to Spark AI Summit, and good morning. This conference was started about 5 years ago in a very small little hotel, just a few blocks away from here, and the time was only a couple hundred of you. And look around. I'm super excited to see almost 5,000 of you here today. And you're here to exchange knowledge, to share ideas, to learn about what's going on in Spark and also its ecosystem. And more importantly, you can take that knowledge home and apply it to your next data pipelines or applications. So one of the things you care a lot about is what's coming, what's next. And in this conference, we have a lot of exciting announcements for you, and starting with Spark itself. So what's next for Apache Spark? Spark 1.0 was released about 5 years ago in 2014. Spark 2.0 was released about 2.5 years ago in 2016. You could probably guess it. Apache Spark 3.0 is coming later this year. Now, there's going to be over 1,000 features, improvements, bug fixes in Spark 3.0. I won't have time to go into all of them here. As a matter of fact, I highlighted some here, and I can't even go onto every one of them. In the context of this talk, I'll be talking about a couple different changes in the context of this project's design principles. And you'll be hearing more about Spark 3.0 on blogs, on Twitter in the next few months, so just stay tuned, all right? Now, for many of you that have been using Spark for a while, you know that Spark's been around for a few years, and it's also changed a lot over the years. But you probably also know that the project principles that led to the creation of Apache Spark itself still hold true today. And I want to share with you 3 of them today. And for each one of them, I'll be talking about how Spark was initially designed to address that, what has changed in the past couple of years, and what we're doing in response to those changes. And the first is unified data and AI. Second is run everywhere. And the third is providing beautiful, intuitive, and easy-to-use APIs. But all 3 really boils down to one goal: to make you, the data scientists and the data engineers, more productive. Now let's dive into the first one, unified data and AI. Spark was the first, what we call unified analytics engine that combined big data processing and machine learning. As part of that, we built Spark MLlib, which is distributed machine learning, a high-quality distributed machine learning implementation for a lot of different algorithms on top of Spark. And we packaged it as part of Spark itself and became part of Spark 1.0. But in the past couple of years, we have seen a rapid explosion of machine learning frameworks. A lot of them are driven by deep learning use cases. For example, TensorFlow, PyTorch, MXNet, and a lot of that. A lot of the users of these deep learning frameworks, when they want to put the frameworks into production, they need to feed a lot of data in these frameworks. And they realized most of the data is already in data lakes, and Spark is the de facto interface to all of this data. So they wanted these frameworks to integrate really, really well and run out of the box with Spark. But they run into challenges. And in response to that, we started on this stage last year, we announced Project Hydrogen. And Project Hydrogen aims to bring all of these deep learning frameworks into Spark with first-class support. And there were 2 major pieces that have been delivered in Project Hydrogen in the last 12 months already. The first piece is the ability to push data in high throughput to this machine learning frameworks, what we call vectorized user-defined functions, or Pandas UDFs, for some of them that have been using it. The second piece is a major change to Spark scheduler called barrier scheduling that reconciles the execution mode of Spark and all distributed MPI programs, which a lot of the frameworks are built on. In Spark 3.0 and beyond, you should expect 2 more major pieces that will be delivered to complete the story of Project Hydrogen. The first one is accelerator-aware scheduling. So now you can leverage the latest FPGAs and GPUs to accelerate your machine learning workloads. And the second piece is to a more generalized version of the vectorized user-defined function to allow you to push data in high throughput to these machine learning frameworks. And it doesn't just work for Python now, but it also works for the JVM languages as well. To learn more about Project Hydrogen, Xiang is giving a talk tomorrow at 2:40, and I encourage you to check it out. Right. Now, of course, we're not just here for Apache Spark itself, but the entire ecosystem. And MLflow was another project we started and announced on this stage last year in response to all of these changes. And to learn more about MLflow, Matei will be giving a keynote on it tomorrow about MLflow 1.0 and starting at 9 o'clock, so don't miss it. The second principle I want to talk to you about is to run everywhere. Spark was initially created to run on Apache missiles, and a lot of Spark users even today run on missiles. But very quickly after that, we realized we really wanted a way for developers to rapidly iterating on their data pipelines when they're in development, and want a way for them to test the pipelines without a lot of overhead of the clusters. So we created a local runner mode that you can run Spark on any single machine. Could be a laptop, could be a server node. And then Spark was integrated with Hadoop. So there's a great way to actually run Spark out of the box in Hadoop data lakes with the YARN mode. And then as Spark itself became more and more popular, users came to us and asked, hey, I just want to run Spark as a unified analytics engine without the overhead of managing Hadoop or Mesos. Can you give me that? It's a lot of trouble to set up these things when I only run one thing. So we created a very lightweight scheduler mode that manages resources across a cluster called Spark Standalone mode. And it's a very simple way to set up to run just Spark and Spark only. But all of this were created to make, back then, mostly data engineers and later on data scientists' job easier because it makes it easier to operate and deploy Spark. Now, similar to the machine learning space, the resource management space has also seen a lot of innovations in the past couple of years. And on the slide here, I've shown you a Google trend comparing Hadoop versus this new technology called Kubernetes. As you can probably tell, even though Kubernetes is less than 4 years old, it has generated more search query interest than Hadoop. As a matter of fact, it's more than double or triple the amount now. And a lot of it is driven by cloud adoption and the rise of containers. So the Spark community saw this trend coming almost 2 years ago, and it was actually a very big collaborative effort with multiple companies behind it that started an effort to add native Kubernetes support for Spark. A lot of it was delivered in experimental support fashion in Spark 2.x. And in Spark 3.x, you should expect this functionality to GA with a lot more hardening for production usage, and also some of the critical features like dynamic resource allocation and external shuffle service. Right. I'm personally super excited about this. At Databricks, about 2 years ago, internally we switched all our internal services to run on Kubernetes. So Kubernetes will be the 5th native mode that Spark can run on. And really to fulfill the goal of Spark you should be able to run Spark everywhere there's data. In this conference, there's actually 4 talks on Spark and Kubernetes that you can check out if you're interested in this topic. Now let's talk about the last principle. It's about creating easy-to-use APIs that are intuitive. And it's actually my personal favorite. I spent a lot of time thinking about that when I was working on Spark. And as I was preparing this presentation, I digged up a lot of the talks we gave earlier on before Spark was popular. And on the screen here shows you 2 slides from a 2013 talk I gave. And you could see at the time we pitched Spark before it was popular as, hey, it's a fast, expressive cluster computing system interoperable with Hadoop, and focus on, in particular, 2 aspects. One is performance. You could get up to 100x speed up over Hadoop MapReduce. And second, its usability through high-level APIs in a lot of different languages. And Spark APIs, back then called the RDD API, allows you to express your program in a much more concise way that allows the program to be more readable. It allows you, the data scientists and data engineers, spend more time focusing on application logic rather than just fiddling with the framework's APIs. Right. It became very popular. A lot of the Spark users initially came to Spark for the performance gains they would get, but really stay, I think, with the APIs. Now, we didn't just stop there. After Spark became a little bit more popular, worked with more and more users, we realized a lot of them face a similar challenge they have to work around in Spark's RDD API, which is a lack of schema support. For a lot of the data pipelines, even though you might start with unstructured or semi-structured data, but somewhere along the way, you try to give data structure. It's how data typically is. And when you give data structure, it's tremendously useful to have the concept of schema. You know what data types things are, you know how many fields there are. And the way typically people do it without when the framework itself doesn't give them schema support is they use the tuple concept in the native programming languages. For example, in Python, you'd be using square bracket. In Scala, you'd be using underscore. So when you look at a typical Spark program back in 2013 and 2014, you will see that the litter with square brackets and underscores, making the program very difficult to read. And here's one example on the slide. So in response to that, and also inspired by the similarly named data frame concept in Pandas and also in R, we created a big API revamp, introduced this new API called data frames in Spark. And after that, with the introduction of data frame API, we saw an uptick of usage by data scientists in Spark. And as a matter of fact, data frame API is now the de facto API. If you're new to Spark and you're learning APIs, very likely you don't even learn about the ORDD API anymore. You just learn about data frame API. As more data scientists get on board and started using it, we saw another interesting trend, which is many of them struggle with transitioning into Spark. And in order to explain that, I have to talk to you a little bit about a typical journey of a data scientist. Many of you are here today. So first, you have to learn about the skills of data science. You have to sort of learn the technical skills, you have to learn the theoretical foundations. And back then, typically you do it through MOOCs or through books. MOOCs is in online classes. But these days, there's also university programs for data science that you can learn. Now, one of the things that's almost universal across all of this is they teach 1.2, and sometimes only 1.2 only, which is Pandas. Pandas is the de facto standard for data frame on Python in the PyData ecosystem. And when you graduate, you start getting into a workforce, you started participating in competitions on Kaggle, and you analyze typically small to medium-sized data sets in which Pandas is a great fit for. It's exactly what Pandas is designed for, small and medium data sets. And then at some point along the career, you want to analyze a larger data set in production that's already hosted in some data lake. And you realize you're stuck because Pandas is fundamentally a single node, single-threaded in-memory implementation of data frames. It doesn't scale to larger amount of data. And your more experienced colleagues would tell you, hey, you should use Spark. That's what we all use. There's this data frame API even in Spark. And they're very similar. Just go use it. So you started using it. And then you realize, yeah, I've heard Spark data frame API is inspired by Pandas and actually implements in the API in a lot of similar ways. For example, it's the same way to access a column. But they're also quite different. There are different ways of adding a column. There's different ways of renaming a column. There are different ways of doing value count. Sometimes Spark's a little bit simpler. Sometimes Pandas a little bit simpler. But they are different enough that now I have to relearn everything. And these subtle differences really create a lot of friction. It's not necessarily that the data scientists can't learn about a new API, but it just creates friction. They just want to get their job done. They're not necessarily interested in learning a million different frameworks and APIs. You've probably been wondering what the hell's going on with the stuffed animals on stage. The pandas, a bunch of koalas here. All right. To fix that problem, to make the job of data scientists easier, we're announcing a new open source project here today called Koalas. So, as the title suggests, it's a very simple thing, very simple to understand. It provides a Pandas API on Spark. All right? There are two goals. One is to reduce friction. We want data scientists to be able to use big data without learning a whole new framework. Second, we want to create a new unified API that you can work both on a small laptop and on a large cluster without changing a program, except a single line of import from Databricks import Koalas. There's no better way to demonstrate the power of Koalas than a live demo itself. And with that, I would like to invite Brooke onto stage.
Thank you. Thank you, Reynold. My name is Brooke Wenig, and I'm the machine learning practice lead at Databricks. As part of my job, I spend a lot of time helping customers scale their single-node data science solutions using Apache Spark, which often involves significant code rewrites from Pandas data frames to Spark data frames. In addition to Spark's learning curve, this is a time-consuming process and can often introduce errors. That is why I'm very excited to introduce Koalas to you today, a unified API to run your Pandas code at scale using Apache Spark. For this demo, I will use the very topical San Francisco fire calls dataset. I will guide you through a typical data science workflow to predict response times for the San Francisco Fire Department so we can build a solution that scales to fire departments across the country. Let's get started. We've got some firefighting koalas to help us out. So as you can see here, I've already written some Pandas code to read in a CSV file, select some columns, and display the results. But we can see this took almost 2 minutes when I ran it. So what I'm going to do is I'm going to copy and paste this code down below, change the import from Databricks, import Koalas, and now all I have to do is replace my Pandas code with Koalas. And so I get to keep my same code that I wrote with single node Pandas, but now it's going to be running against an Apache Spark data frame. And we can get our results much more quickly. I can see I got them in 8 seconds now. So that is a 10x speed up. And this data set is only on the order of a few gigabytes. And this solution will scale linearly as our data set increases. And so even though I've been using Spark for 4 years, I teach classes on Spark. There are still some things that I actually find easier to use Pandas for. One of them is getting the value counts for my data frame. And you can see just how quickly that ran. And so we can see here, the San Francisco Fire Department receives more medical calls than they do fire calls. And they only receive a handful of lightning strike investigation calls. But that doesn't mean that we're locked into using the Pandas syntax if we use Koalas. Because Koalas runs with Apache Spark as the underlying execution engine, that means we can switch between all of the languages that Spark supports, including Spark SQL. So now I can easily switch into SQL and continue my exploratory data analysis there. And so if any of you have tried calling the fire department with an administrative call, you're going to wait a while. Luckily, they respond much more quickly to the things that are a little bit more time-pressing, like traffic collisions and fires. So now that I've read in my data, I've done my exploratory data analysis, it's time to do some feature engineering. And for that task, I'm going to use this technique called one-hot encoding to convert our categorical features into a numeric representation a machine learning model understands. So first step any data scientist does, go to Google, see if there's any libraries that do what you want it to do, and if not, copy and paste code from Stack Overflow. So let's go ahead and do a search for one-hot encoding data frame. And I can see here the first search result is Pandas get dummies, as well as these other ones down below. So because I'm pretty lazy, I just copy and paste this code and pray it works. Display. And all I have to do to one-hot encode is change my Pandas to Koalas. And now you can see how quickly we can one-hot encode our data frame and how simple that is. But we're not done yet. Now that we've done our feature engineering, it's time to apply a machine learning model to our data set. And no better way to do that than to highlight some of the power of MLflow. With MLflow, I can load in my saved scikit-learn model and create a Spark user-defined function so I can do model inference at scale on my Koalas data frame. So here, I can make my user-defined function, predict the time delay given these input features, and see which neighborhoods have the highest and the lowest predicted time delay. Maybe next year we'll host the Spark and AI conference in Haight-Ashbury. Thank you very much.
All right, thank you, Brooke. What Brooke has demonstrated to you is even with a moderately sized dataset, it's 2 GB San Francisco Fire Department call dataset, you could get substantial speed up with Spark. But now even better, with Koalas, data scientists are even to learn a new language or new API to leverage Spark. Koalas is open source today. You can find the GitHub repository here under the Apache Spark 2.0, Apache 2.0 license. It's also published to the Python package index PyPy, so you can just install it with a single line on a laptop. Pip install Koalas. There's nothing you have to set up. You don't have to set up Spark, just runs on a laptop. It's also available on Databricks. Just go read the README here. All right. So what I've talked to you about today is 3 design principles: unify data and AI, run everywhere, and creating easy-to-use APIs. These are not the only design principles in the Spark project, but are the 3 major ones that's really driving the project, not just the project, but also the surrounding ecosystem forward. It drives Apache Spark, drives Koalas, drives MLflow, drives all the other projects. But really, they boil down to one purpose. It is to make all of you here, data scientists and data engineers, more productive in building our data pipelines. And I can't wait to see what you'll be building with it. Before I get off, we got a couple Koalas here. Anybody wants them? I've never played baseball, so. Sit closer to the conference stage next year. And I'm going to keep one for myself. All right, thank you. Enjoy the conference.